Dear students, the previous video we have seen the general outline of metrology and measurements. What are the 5 units described, and what are we going to discuss in all the 5 units discussed in brief. Now we are going to the unit 1. The unit 1 we are going to discuss about basics of metrology. In the previous video we have been discussing about overall view of metrology and measurements. What are the things we are going to study in detail, and I have discussed unit 1 what are the things we are going to see in the unit 1, that is basics of metrology. In the unit 2 we are going to discuss about linear and angular measurement. In the unit 3 we are going to discuss about advances in metrology, and unit 4 form measurement, and unit 5 measurement of power flow and temperature. Now in the second video I am going to discuss about the unit 1, which is basics of metrology. Why metrology is required? So metrology is nothing but science of measurement. So in industries, manufacturing industries, we need measurement of every component what we are going to manufacture. So in the product design, while drawing the diagram, we have to clearly mention the dimension. So according to the dimension, the production engineer will manufacture and measure to the dimension, and he will say that it is of correct dimension as mentioned in the diagram. So metrology, that is the science of measurement, plays vital role in all walks of life. Even if you go to the grocery shop, you will measure and purchase. So that much importance the metrology plays in our day-to-day life. It has a wide range of applications, not only in the engineering or production field, also it has wide range of applications in aerospace, automobile, and biomedical and health departments and medical field. Almost in all the fields we have found the application of metrology. As far as the subject is concerned, in the unit 1 we are going to discuss about introduction to metrology, need of measurement, why we have to do the measurements, and what are the ways and methods on which we are going to do the measurement, and elements of metrology and characteristics of measuring instruments, errors in measuring instruments, and types of standards. These are things we are going to study in second unit. Okay. Definition of the metrology goes like this. So it is a science of measurement, as many definitions give different wordings for defining the metrology. In simple terms, we can say that it is a science of measurement. Here we are going to deal about precise measurements of the relative positions and orientations of different optical and mechanical components. It is a process. Measurement is defined as a process of numerical evaluation of a dimension with the standard measuring instruments. Check how to measure things. We have to quantify, and we have to check whether the item or component or a piece within the given tolerance limit, and how we are going to control the measuring process, like statistical process control. So the need for measurement, interchangeability is one of the important parameter why we are going for the measurement. So across the globe, if you want to change the components or spare parts of a particular equipment, we do not go to the parent place and we have to replace. It's not so. Anywhere we can purchase the required spare part and we can replace with the existing worn out spare part, because it is possible only because of the concept called interchangeability. That is, we are making the component with the required dimension and with accuracy and precision, so that that particular component can be fitted to any other equipment where we need of a similar component. There are different methods of measurement: direct method, indirect method, comparative, coincidence, contact, reflection, and complementary method. So this is if you are measuring with the vernier caliper and if you are seeing the reading, and that is called direct method. Indirect method, if you want find the weight of certain component without measurement. So what we will do, if you want to calculate the weight, we can multiply length, breadth and height. That is volume and density. If you multiply volume and density, it will give you the weight. So without using any direct method, we are measuring the weight of the component, weight of the particular object by using indirect method, that is mathematical formula. This is a comparative. By using the comparators with a known value, we are going to find the difference. That difference will be measured. That is called comparator. So indicate the difference in size between the standard and the work being measured by means of some pointer on a scale at a magnification which is sufficient to read the accuracy required. How much the deviation is there. So particularly it is used to find deviation in the measured object. This is the contact method as we have seen earlier. This is coincidence in screw gauge, micrometer or vernier caliper. We are using this. The coincidence of main scale reading and vernier scale reading will give you the final reading. This is a complementary method, volume determination by liquid displacement. This is a deflection method as we are seeing in many places in weighing machine. Transposition method. Transposition method is the simplest way, that is involves making the measurement direct by direct comparison, whereas the quantity to be measured is V. For example, quantity to be measured is called V. Is initially balanced by known value, that is capital X, of the same quantity. You carefully listen. So the quantity to be measured is capital V, and it is measured initially. It is balanced with a known value capital X of the same quantity. Okay, that is one set of reading. In another set of reading, that X is replaced by Y of the same quantity. If X and Y are equal, then capital V, that is the quantity to be measured, is equal to square root of XY. That is root of AB. According to this diagram, root of AB will give you the quantity to be measured. These are the generalized measuring systems: primary measuring system, variable manipulation, data transmission, data processing, and data presentation. These are the generalized. That is a flow chart how we are going to measure the measurement. Various elements of measuring system: a standard, workpiece, instrument, person, and environment. Standard workpiece It should be of clean, tidy, does not have any uh, unwanted materials, scratches. It should be of good finish. That is the basic requirement before doing the measurement. Elastic property also will influence the measurement. Supporting the workpiece will also influence the measurement. Another thing is instrument, which is a device used to measure the measurement. And person who is going to measure, the metrologist, should be of a skilled labor. He should be able to correctly select the proper measuring equipment, instrument, and do the measurement with accuracy and precision. Environment will also play the role in measurement, like temperature, humidity. The temperature, 1 degree temperature variation will result in zero point 0.3 micrometer. For example, if you take the length of a piece, if the temperature is varying by 1 degree, the length of the object will vary by zero point 0.3 micrometer. So the temperature will influence. So we have to measure the workpiece at standard temperature and pressure. Across the globe, they have given that standard temperature is 20 degrees Celsius and standard pressure is 760 millimeter of mercury. So the standard units we are going to have is length, mass, time, electric current. Length is measured by means of meter, mass is by means of kilogram, time is means of second, electric current ampere, temperature Kelvin, amount of substance mole, and luminous is candela. So with this I stop the unit 1, and in the next video we will be discussing about second unit, which is nothing but linear and angular measurement. Thank you for listening.